Over a year ago, I made a tutorial for creating different shapes in Blender. But looking back on it now, it isn't that useful and doesn't show very practical shaders. But now I'll show you not just better square shaders, but an N-gon generator that can be used for all kinds of things. But before we get to the big stuff, here are some even easier ways to make useful shapes. Since my last video on polygons, I've learned of a way to make squares with just two nodes. Absolute and separate HSV is all you need to make a square gradient. Using a less than node allows you to define its side lengths. I actually picked this up from CMZW's channel, which is an amazing shader resource on YouTube. I'll make sure to have a link in the description for it. But the square SDF is a significant upgrade from the regular square. SDF gradients denote the distance from a certain shape. Values above 0 extend away from the shape, whereas values below 0 go inside the defined shape. The reason SDFs help us is because at higher distance values, they round their input shape. And to make this with a square, all we really need are our coordinates. Let's use an absolute node, a subtraction, a maximum, and lastly, a length node. This gives us the SDF of a square. If that's all you need, go ahead. But if you want to understand what's going on with this shader, we should look at each node separately. First, our vector absolute node flips negative vectors. This acts as a symmetrize on the x and y. Next, we use a vector subtract operation. This defines our square with values of 0, which we can see as the border between color and black. Then we remove the unseen negatives we get after subtracting. We do this with the vector maximum. And for this input, we set all values to 0, meaning the x and y values remain above 0. Lastly, our length operation converts our vector input into a float map. With greater vector distances from 0, 0, 0, it increases in value. Now you can use a less than operation to change the roundness of your shape. For a circle, I use the same setup as shown in my previous video. That's because it's a simple length node, that's all. Although while we're here, you can really see how the absolute node is just a mirroring function, and how removing negatives logically gives us a square. But on top of making rounded shapes, SDFs have the property of blending between one another. All you need to do is mix two SDFs. You can use a less than node to make the shapes more defined. Now these specified setups are very fun to make, but making a custom shader for each polygon is pretty slow for a video. That's why with this upcoming shader, we'll do them all at once. What I mean by that is that we'll build a shader that has an input for any number of faces, n. We start by placing a gradient texture at the center of our coordinates. I like to rotate this gradient by 90 degrees and invert it. Invert the 1 and 0 values any way you want. In my case, I'm swapping the 2 values on a map range node. That's these bottom two sliders. And having done this, our gradient now increases in a clockwise rotation. For the next step, we'll need 3 nodes: multiply, floor, and divide. But we want to make sure to multiply and divide by the same number, which we can do by adding the same value node to the 2 inputs. We call this value n. And through this process, we've segmented our radial gradient into n slices. Let's try moving n to see our effect. As it increases between whole numbers, we get fractional numbers of slices. And to mitigate this, we floor n, which rounds our value to integers. And we'll be using this rounded n for the rest of our shader. Increasing n now means we have discrete segments with their own values, no matter the value of n. From here, it gets a little advanced. Conceptually, all we want to do is use our segmented gradient to inform the rotation of our coordinates. We will now plug in our coordinates into a vector rotate node. And here's a quick tip. Add a vector math node and subtract by 0.5y to help visualize this shader. Now let's avoid plugging our gradient directly into the rotation for now. We know that a value of 1 plugged into a vector rotate node does not equal a full rotation. And in order for us to get a full rotation, we need to convert our rotation input into radians. Radians use multiples of pi to represent angles, where half a rotation is equal to pi radians. That means 2 pi gives us a full rotation of 360. So logically, we can multiply our rotation input, ranging 0 to 1, by 2 pi, so it ranges from 0 to 2 pi. So let's add that operation now. We'll plug our gradient with n segments into a math node, set it to a multiply, and set the unconnected input to 2 pi, which we can simply write as tau for short. By now, we're actually extremely close to being done. Our coordinates are now set up locally for each slice of n, but there is one problem. They are centered on the edges between segments, as opposed to being on the middle of each segment. And in order to center them, we'll go back to our graph before the multiplication of 2 pi. We can now add the reciprocal of n to our segments. We'll just add a divide node, set it to 1, and add n to the bottom socket. The ordering here is critical. Because we're looking for the reciprocal of n, we want 1 to be at the top of the operation. And now that we've added this, we've effectively added an entire extra rotation to all of our segments. But to counteract this, all we need to do is multiply our reciprocal by 0.5 before adding it. Now we've added half a rotation to all segments, effectively centering the coordinates on the middles of our segments. And for our next step, oh, it's finished. Well, that wasn't too difficult, I'd like to think. We can now super easily just separate the y-axis of this shader to get any polygon possible. But there is an alternative use for this. Having done this process as a rotation of our coordinates, we can practically instance any kind of texture onto the points of this N-gon. For example, we can take our rounded square shader from earlier and replicate it at the end of this node graph, essentially allowing us to duplicate it many times over and instance it radially. This is already incredibly useful, right? But there is still room for even more functionality for you to add. Like, for example, you could rotate by the inverse of the segmented gradient to swap the orientation of the coordinates to global space, and all of this in such an elegant node group. Altogether, polygons are super fun to make in shaders. They can be very accessible or very advanced, making them truly a great way to challenge yourself. I plan to optimize this elegant shader even more in the future, but for now, I hope this was fun to follow along, watch, or just think about. Thanks.